Welcome to week 7, lesson number 3. Today, we're going to talk some more about hydrocarbons, specifically about where they come from and some of the specialty other hydrocarbons besides the ones we talked about in our last lesson. One of the most important in our industrialized world is petroleum. The name petroleum comes from petra, which means rock, and oleum or oil. So you get oil out of the rocks, basically. That's what petroleum means. It's also sometimes known as crude oil, where it's just the rough oil that comes out. And crude oil has all kinds of mixes of different hydrocarbons. Now, in the 1800s, chemists found that they could separate crude oil in a process called fractional distillation. And that's where you distill and different parts are able to be separated based upon their different condensation temperatures and things like that. So it's fractional distillation where you can split it. But before they figured out how to do that, most crude oil wasn't very valuable. Back in, there used to be tar pits that people could find, and there were some small uses for them, but for the most part, most of the oil in the early 1800s and earlier was whale oil. And books like Moby Dick and things like that are all talking about the whale industry, which is pretty much stopped on Earth now. The only country that really continues to do whaling is the Japanese. Most other nations have pretty much given up on whaling because they've driven some of the different species of whales to extinction, and others were really small populations of them. But what they would do is they would get the whales and they would synthesize their fats into oils, and they would use that for lamp oil and certain types of things like that. So, but in the later 1800s, right before the turn of the century, right around that time period, as the internal combustion engine started to be used, there was a need for more oil than just the whale oil and stuff like that. And so there started to be a need to really go hunt for crude and stuff like that. And a lot of the original drilling that was done and getting this crude oil was pretty shallow, because you could find it at all different stratas in the earth, and they could drill and they could get some of this crude oil. But this crude oil is really heavy, it's thick, it has all kinds of impurities, and that's why they need this fractional distillation. Now, on page 324, up at the top, is table 18.5, and we want to kind of go through that a little bit. So it says natural gas, methane, ethane, LP, which is liquid propane gases, which also are kind of in the propane and butane, and those are in the numbers of 1 to 4 carbons. Their boiling point is less than 40 degrees Celsius. I mean, some of them are really low temperatures. They also are used in some plastics and fuels and plastics. Now, gasolines can be anywhere from the 5s to the 10s, but most of them are going to be in the 8s and higher, and they're used. These kinds of hydrocarbons are fuels and solvents to try to clean up things and stuff like that. Kerosenes and diesels and things like that start at about 10 to 18 carbons. And also jet fuels, some home heating. Like if you were to get what's called fuel oil, it would be really heavy oil. When me and Sister Sarah lived in Nephi, we were living in a home that used fuel oil, which was a real heavy. It's even heavier than kerosene. It's just a heavy oil that's used in the furnace to heat that home. Sometimes people also have coal oil, which is kind of a crushed up oil and stuff like that. Heating oil, here again is the next one down. Those are in the 14 to 22s. Industrial heating. Sometimes it can be heated in this fractional distillation system and you can get some gasolines out of it. Lubricating oils, like the oil you put in your car to keep things greases and things like that, they start to get even thicker, but your standard lubricants start with about a 20 to 30 carbons in a chain, and then you get the residues that comes off the very end. That's the last stuff. This is all the process of this fractional distillation, and those residues are things like paraffin, wax, and asphalts, and tars, and things like that. Now right below that table is a tower that's a fractional distillation tower, and they pump the crude oil in with a super hot heaters, and the residue goes down and comes out the bottom, and as it goes up, the heaviest stuff sloughs off first. That's going to be those lubricating oils, greases, and paraffins and stuff like that. And you go a little bit higher, you're going to get your heating oils. A little bit higher, kerosene's going to come off a little bit higher. You're going to get your naphthas and things like that. A little bit higher, you're going to get gasoline, and then off the very top, it's going to go out the top, are those things that are in gas form naturally at normal atmospheric temperatures and pressures. Things like methanes, ethanes, propanes, butanes, things like that. They're going to come off the top, and they will capture those and try to split those up into their different forms. Now, a lot of the natural gas that is collected around the world is not even collected at this point. It's direct pipe. When they drill down in, they'll get pockets of natural gas that they can collect, large pockets, and it directly comes up and they collect it directly at that point. And so this stuff, they still do it here as well, but most of the natural gas that's being piped into places is that they've learned to be able to cap that and keep it for use in homes and other types of things. So in the 1940s, so from the late 1800s to the 1940s, they were drilling it mostly to try to get fuel for cars. They weren't capturing most of those gases that were just let go free. It was just mostly after getting greases and fuels. But in about the 1940s, around the time of World War II and a lot of those, they started to develop synthetic fibers and plastics and things like that. And a lot of those were using some of these heaviers, but some of the lighters too, depending on the type of plastics and the types of things. And synthetics are used in all types of things, from the type of chairs you sit on to half of automobiles anymore. I mean, a lot of your clothing is your nylons, and all these different things are made up of synthetic materials. Now, to get the fuel, you first have to drill down, find the oil, then you have to get it out of the ground. A lot of times it's piped to a tank or a storage, or in some cases it's piped long distances to where then it either goes to ships or trucks, and then it's hauled to refineries. And at the refineries, that's where these fractional distillation things take place. There's a refinery up in North Salt Lake. If you drive out of North Salt Lake headed towards Bountiful, you'll drive past several refineries right along there where they are refining the fuels to get these different products. Now, the piping process, right now there's pipes that are coming into the United States out of places in Canada. There's pipes that are coming out of places in the Dakotas that are running fuels down to the Mississippi River, and they're hauling it down to the Gulf to get to a lot of the huge refineries that are down around Louisiana and down around there. Sometimes they go out into the ocean and they have these great big oil drilling rigs that are out in the water. If you go back to page 323, you can see some of those oil rigs and those big oil ships, and just underneath the ship, you'll see a pipeline there. That's the Alaskan pipeline, or also known as the Alcan pipeline. It goes from the northern shores of Alaska clear up in the Arctic, right up against the Arctic Ocean. There's a lot of oil that was found up there, and they pipe it in this giant pipe that's about 3 foot in diameter, and it has insulation around it, and so if you're right next to it, it's about this tall. There's this great big pipe, and they pump it hot. It's still crude. They haven't refined it. They pump it as crude, but they pump it hot enough that these paraffins and stuff remain good and liquid, and that's why the pipe's insulated. And they pump it all the way across Alaska down to the southern part of Alaska, where there are ports that don't get frozen in the winter, down by Valdez. And these great big giant oil tankers that's just above that pipeline come in and fill up, and they take them all around the west coast and probably even clear around over to the east coast of the United States and other places to get the oil refined. Most of that is still crude, and it's sent to one of these huge oil refinery systems to get refined. Now, if you look at this pipeline there, it's up on these stilts, and on top of those little stilts you see this little silvery radiator, and more like aluminum, where the stilts are painted red, and up on top is this that radiator, and that radiator is on purpose. There's these pipes that go down into the ground, where those pipes go really deep down into the ground, and there's a natural refrigeration process that's happening. It comes up and evaporates, cools, sends cool back down into the ground as it sucks heat out of the ground. The heat comes back up and is radiated out, cools, sends the cool back down in, and it tries to keep the ground frozen, because most of Alaska has what's known as a permafrost. Sometimes the surface will thaw, but what's underneath is permanently frozen. And because this pipe is heated, they can't put it on the ground or in the ground. And if it was to melt through going over and melting down in the ground, those would become unstable, and it would mess it up. So they keep the ground permanently frozen. And every one of those stilts for thousands of miles across Alaska are not that far apart, maybe 30 feet apart or so. They're really close, and every one of those stilts, back when it was built 40 years ago, 30, 40, maybe even 45 years ago, it was back quite a long time ago when it was first put in. Each one of those stilts when it was built was $13,000 a piece. So as you're looking at that, there's just tons and tons of money. And some people said at the time that it was a huge waste of money. Well, as soon as it hooked up and started pumping oil, it pretty much paid for itself in a matter of just moments. In fact, the state of Alaska takes a lot of that oil that's coming out of Alaska and collects it, and people who are native-born Alaskans actually receive a check every so often because of the profits that are made off of the oil that is shipped through this pipeline. And then below that you see the trucks. Those trucks are necessary sometimes to haul stuff to the refineries, like in the state of Utah. We have oil that is drilled out in the basin area, out by Vernal and Roosevelt and they take and put those on trucks and haul them up to the refineries up at Salt Lake. And then from those refineries you get the quality fuels or whatever type it is, and if it's gasoline, then it's put in those trucks again and hauled to the gas station where it's put in so that you can pump it into your car. So it's a fairly involved process, but very, very important in our modern society. Now, gasoline is extremely valuable, but of the crude oil that comes out of the ground, only about 20% of that is actually converted into gasoline. Lots of it are converted into other things. Now, and we talked about the natural gas that comes into your house. That's made up of about 97% methane. Coal is another hydrocarbon, but it's so thick and heavy and mixed with fibrous that it's not a liquid, but it's made up of about 95% carbon. I mean, depending on if it's a good grade. If it's a low grade carbon, it might be 45. There's a lot more dirt in it. But so when you burn it, you end up with a lot more sandy dirt. If it's really, really high quality top stuff, then it might be as much as 95% carbon. It's used for power plants and for heating homes. I mean, it's also used to make the coke, where we talked about when we were talking about steel and stuff like that. You need the coke, you have to burn off all of the impurities, but there's no oxygen, and so the carbon is allowed to be there, and it's pure carbon, and that's the coke. For steel manufacturing, now there's a lot of talk about global warming and whether or not the higher the carbon levels in the atmosphere of CO2, the more plants grow. That's a natural cycle. It's one of those things that there are models that say that the Earth is actually possibly capable of going into cooling. And in fact, in the 1970s, there were many, many scientists that insisted that the world was on the verge of going into a global ice age that would affect millions and millions of people and kill off millions of people, and they wanted the governments to go put a whole bunch of black dust over the polar ice caps to keep the world warm. So there's a lot of things that the world is warmer right now than it was at the time of Joseph Smith. There is no doubt about that. What is causing that and what proportions are causing that is where the debate is. Whether or not what we're doing as humans is creating the major difference, or if it's part of the natural ebb and flow of temperatures that have been going on Earth for thousands of years. In fact, a lot of the coal that is mined from areas that were crushed forests, rainforests, that got buried in some kind of floods or landslides, and then they were put under pressure and compressed, and over time they turned into coal. The petroleum that we get out of the ground, the crude oil, there's a lot of debates about where and how that came about. Back when I was in school, it was almost all about little microbes that were caught. In fact, it's kind of funny because Sinclair has the dino, and they used to say that it was the dinosaurs that got caught and compressed. But pretty much the oil, when they're drilling for oil back in the 1980s and stuff, a crude oil engineer would be searching specifically for certain fossils of little microbes to tell if they were getting close to what he thought would have large oil connections. But over the last 10 to 15, 20 years, they've had to drill deeper and deeper and deeper in order to find oil. And the deeper they drill, the bigger the oil reserves they find. And there are many scientists now that start to wonder if most of the oil that is on the earth was trapped at the time that the earth was made itself. Since there's lots and lots of methane out in space, if you trapped it and under pressure and that, you could create longer chains of hydrocarbons. To be honest, most people, nobody really knows other than Heavenly Father. Heavenly Father would know how all that came about, but they're finding it much, much deeper than they ever thought they would, because they always assumed that at one point in time it had to be on the surface. But now they're drilling super, super deep out in the Gulf of Mexico, where you have these pictures like of this drilling, oil drilling out in the water. They can be miles and miles and miles out and drilling super, super deep, cleared way down deep in the bottom of the ocean. And not only is it way down deep, but then they're drilling deep into the ground. And so there's really a question somewhat as to where those come from. Now, you can get fuels from plants directly. If you take something like corn, you can get corn oil. You can squeeze things. You can get canola oil. You can get coconut oil. There's all kinds of grapeseed oil. There's all these different oils, nut oils. There's tons of different natural plant oils that can be turned into fuels as well, and they are hydrocarbons as well. And next I want to go to page 327, 18.3 in your book. So here we're going to talk a little bit about the alcohols again. So I mentioned it in the last lesson. We talked a little bit about alcohols. And right down on the bottom of that page, you'll see a methane, a single carbon with 4 hydrogens. So this is methane. Now, if you change it by just adding 1 oxygen, so we're going to take this guy right here, and we're going to add 1 oxygen, and so we're going to add a hydroxide ion right there. This is, instead of being methane, it's methanol. Now, this is heavy enough that it's actually a liquid. Methanol is a fairly lightweight alcohol, but it's still a liquid. And methanol is like a wood alcohol. When people get into making their own, distilling their own liquor, sometimes some of the first stuff that comes off and boils off initially will be methanol. And you've probably heard of people going blind and stuff like that because this is a toxic alcohol. Not that a lot of alcohols aren't toxic anyway, but this one's toxic and can make people go blind and insane and stuff like that. Now, the next stage of distillation is ethanol. Now, ethanol is grain type alcohols. In fact, if you go over to the gas station and you're putting fuel in your car, there's usually a little note that'll say up to 10% of this fuel is ethanol. It's usually made from corn. It's not a very efficient way to get fuel. It takes almost as much fuel in tractors to farm the corn as the fuel you get out of it to turn into ethanol, but the government subsidizes it to help with that so the farmers can make money. There are other things, there are certain types of reed grasses and sugar canes and things like that that can be turned into alcohols as well, and those are somewhat higher efficiencies. But it's the process of turning, so ethanol would just have, just like the ethane would be like this. That would be ethanol. And isopropyl alcohol is would be like this. Isopropyl is CH3H7OH. And you're going to have an OH. Oops. You're going to have the 7 hydrogens. So that's like a rubbing alcohol. There's a lot of different alcohols, and they can be really large chains of alcohols as well. Nylons and polyesters and things like that are other hydrocarbons which we've already talked about. And hydrocarbons can be used for lots of fancy things, really high-tech, strong plastics and things. But the last thing with the hydrocarbons that I want to talk a little bit about is in biochemistry and some of the things that make up our bodies, like the DNA and the RNA. Those are also strings of hydrocarbon proteins that help to create those things. And so hydrocarbons are extremely important, and that will finish our chapter 18 with the hydrocarbons. We're not going to have enough time to go into them super deep in this year, and we will see you next week to start our next discussion.